Hi, Assalamualaikum. In this video, we are going to discuss example 2 under optimization using second derivative test. These examples from previous semester papers. A closed right circular cylinder of radius r and height h is to be designed so that its volume is 1000 meter cube. Number 1, show that the surface area of the closed cylinder is S equals to 2 pi r squared plus 2000 over r. And number 2, find the radius and height of the cylinder that we use the least amount of material. Right? Right, first we look at number 1. Okay. To solve number 1, okay, step 1, we draw an appropriate diagrams and label and appropriate quantities. Okay. This is closed right circular cylinder, okay, with radius r, height h, okay. This is closed circular cylinder, okay. And then the volume equals to 1000 meter cube, right? And after that, we continue with step 2, okay. Equate an appropriate formula to the given value. The given value here is 1000 meter cube, okay. And then we write h as a subject, naming it as equation 1 because the variable here is r and h, okay. Alright, so from the given value, this is volume, okay, which is equals to 1000 meter cube. And the shape is cylinder. So, an appropriate formula is volume of cylinder, which is pi r squared h. And then we equate to the given value, equals to 1000. Then we write h as a subject. Okay, so we write h as a subject equals to 1000 over pi r squared. Then we naming it as equation 1. Alright. Right. After we write h as a subject, okay, then we continue with step 3. Write another relevant formula and naming it as equation 2. Okay. From the given question, the shape is cylinder. Okay. So this is a 3-dimensional diagram. So the other relevant formula beside volume is the surface area. Okay, so we can write the surface area of the closed cylinder. Okay, we denote as S. Okay, so from here, okay, the surface area of the closed cylinder equals to the top area means area of circle plus the area of the curved side means the area of rectangle plus the bottom area, okay, area of circle, okay. Then we get pi r squared plus 2 pi r h plus pi r squared. So we can simplify pi r squared plus pi r squared. So we get surface area of the closed cylinder equals to 2 pi r squared from here and then plus 2 pi r h, right? Then we naming it as equation 2. Okay. After that, we continue with step 4. Substitute equation 1 into equation 2 here. Okay. So from equation 2, we have S equals to 2 pi r squared plus 2 pi r h. So from h here, we replace by 1000 over pi r squared. Okay, from equation 1. Okay, then we can simplify pi r and pi r from denominator here. Okay, so we get S equals to 2 pi r squared plus 2 times 1000 over r. Okay, and S, surface area of the closed cylinder, equals to 2 pi r squared plus 2000 over r. Okay. And then we compare with the given question, show that the surface area of the closed cylinder is S equals to 2 pi r squared plus 2000 over r. Okay, so this equation exactly the same. Okay, compare with the given question. Okay, so it is shown. Okay. From the previous slide, we showed that the surface area of the closed cylinder is S equals to 2 pi r squared plus 2000 over r. Okay. Then we can continue with question 2. Find the radius and height of the cylinder that we use the least amount of material. Okay. So we refer from S equals to 2 pi r squared plus 2000 over r. Okay. To find the radius and height that will use the least amount of material, we need to differentiate. Okay, so to differentiate, we can write S equals to 2 pi r squared plus 2000 r to the power of -1. Okay, then we can continue with step 5. Okay, we find ds over dr, means we differentiate S here with respect to r. Okay, so after we differentiate, so we get ds over dr equals to, we still have constant 2 pi here, and then we differentiate r squared using power rule, so we get 2r, and then plus, we still have constant 2000 here, and then we differentiate r to the power of -1 using power rule, so we get negative r to the power of -2. Okay. And then we simplify, so we get 4 pi r minus 2000 r to the power of -2. Okay. Then we continue with step 6. Okay. When ds over dr equals to 0, find the value of r. Okay. Our ds over dr equals to 4 pi r minus 2000 r to the power of -2. We equate to 0. Okay. Then we can write 4 pi r minus 2000 r squared equals to 0. We move r to the power of -2 down to denominator. So we get r to the power of +2 or r squared. Okay. Then we can write 4 pi r equals to positive 2000 over r squared. And then we cross multiply, so we get r cubed. And then 4 pi constant here, we move down here, okay, to the right hand side. So we get r cubed equals to 2000 over 4 pi. And then we simplify 2004 divided by 4 here. So we get r cubed equals to 500 over pi. And then r equals to 5.42 using calculator. Okay. And the given unit here is meter. Okay, so we can write radius equals to 5.42 meter. Right? Alright, after we find the value of r, we continue with step 7. Find d2s over dr squared. Okay, to find the second derivative here, okay, we need to differentiate from the first derivative ds over dr, okay, which is equals to 4 pi r minus 2000 r to the power of -2 from the previous slide. Okay, then after we differentiate first derivative here, so we get second derivative, which is d2s over dr squared, which is equals to, we differentiate 4 pi r, we get 4 pi minus here means positive 4000 r to the power of -3 here. Okay. Then after that, to find whether the radius and height is maximum or minimum, okay, we need to find the value of second derivative d2s over dr squared. Okay, either positive value or negative value. So to find whether the second derivative has positive value or negative value, we need to substitute the value of r into the second derivative here. Okay, so after we substitute the value of r, okay, from second derivative 4 pi plus 4,000 over r cube here. We have r cube here. Okay, so we can straightforward substitute r cube. Okay, equals to 500 over pi. Okay, or we can substitute r equals to 5.42, but after that we need to bracket square. Or we can straightforward use r cube equals to 500 over pi. Alright, then we simplify, so we get 12 pi, which is positive value. Okay, or in other words, greater than 0. When second derivative has positive value, means we will get small graph. And small graph here, in other words, is minimum, okay, or least. Okay, so when second derivative has positive, so the graph is small. Okay, small graph means minimum, okay, or least. Okay, alright, then so the question is find the radius and height. So after we find r, we need to find height. Okay, so when r equals to 5.42 meter, so we can find height h. Okay, h equals to 1000 over pi r squared. This is from equation 1 from the first slide. Okay, alright, so from here we substitute r equals to 5.42. Okay, then we simplify or we solve using calculator, so we get 10.84. Okay, because the unit of the radius is meter, so we can put unit for height also equals to meter. Okay, so we can write that. Okay, so from here the radius r here equals to 5.42 meter and the height h equals to 10.84 meter. We'll use the least amount of material, right? From here. Okay, find the radius and height. Coming up next, more example involving optimization. Thank you for watching. Stay tuned. Bye. Assalamualaikum.